Hey there everybody, in this video today we're going to be talking about the graphs of logs and some of the manipulations that are possible with that, and that's what you're going to kind of explore in today's practice as well. So first I just want to talk about and remind us about the relationship between logs and exponents. So remember that a log is simply just the inverse of an exponential function, which also relates to how you look at the graph. So the one in front of us here is an exponential. And if I do the inverse of something, it has a consistent reflection, and that reflection goes over the y equals, if I can select it, the y equals x line. Okay, now that changes some things also when we talk about the exponents too. So here's where we'd probably want to start taking some notes. We'll come back to it, but just a couple of things about exponential graph, we'll call them properties, I guess. So if we use just y equals a to the x, and we have our little graph here. So we saw roughly it's going this way, okay? Now there's a couple things about it. First of all, the domain of the exponential, which is the x values, goes from negative infinity to infinity, goes on forever. However, the range, which is the y values, has a limit to it. And that limit for us is it has to be larger than 0. So it goes from 0 to infinity. Now, obviously, that changes as things are added or put on this exponential function. If we add a negative to the a or the x or add some pieces to it, that can change. But for the parent function, we have this property. And that means that at 0, we have what's called an asymptote. Okay? It's just where it'll get really, really super close but never, ever touch. Okay? Now, the reason why I'm telling you that is because this relates to how we look at logarithms. Okay? Logarithmic graphs. So if it's the inverse, it's going to flip over that y equals x line, and it'll look like that. So there's the log graph when b, in our case, is 2. So they have the same base for us. And what you're going to notice is a couple things. First of all, there are still domain and ranges, and there is still a asymptote, but where the exponent had a horizontal asymptote going left to right around the x values, the log has a vertical asymptote. That's the inverse property for it. Okay, and the reason why it goes vertical, or that it'll never touch that, is simply because then the function becomes undefined. So it doesn't exist there. Okay, but otherwise then also, so hopefully we can kind of recognize that. And then note-wise, so we see that for exponents, we have these properties, which hopefully what you'd understand is that if I do that with a log, so if I go log like that, these just simply flip-flop, okay, where now the domain, here let me change my color so you can see it. So in this case it would go like this. There's our logarithmic graph. Okay, so I have a vertical asymptote, which means my domain, or my x values, would go from 0 to infinity, and then my range would switch from negative infinity to infinity. And that's simply because it's the inverse. But you see there is a relationship between our exponential graph properties and when we have our logarithmic. Okay? So we have those values there. So that's kind of the basics for our pieces there. Now, other things I want you to recognize, or that we're going to kind of let you explore, but I'll kind of mention here, is the manipulation piece on how you can shift, move, rotate, flip, all that stuff with our log function. Now, we've already done stuff with transformations of functions, and the same kind of properties hold with logs, but you're going to be able to kind of see what happens with all those pieces. So all the things that we could do, so I'm going to go back. So again, for some notes, if you would like, this would probably be a pretty good spot. So I go y equals, I'm going to add a bunch of stuff and then I'll talk about what it means. Log let's call it 2 because that was kind of the parent function that we're dealing with. B. Okay. Now it looks like a lot of stuff, but really all it's saying is that, oops, sorry about that. Let me get back. All that it's saying, in our case, is that these are, I guess for lack of a better word, are manipulators. Okay. And it still holds true the same way that we moved around other functions, where if, let me change my color here. Ooh, already changed. So like this was a vertical shift, up or down, based off the positive or negative and the amount. This was a horizontal shift. Okay. And then these kind of either, I guess we could say, squeeze them or make them tighter or wider. Okay. Now, not only the only other piece for this is that this not only changed the horizontal, but that also means it shifts the and I think I spelled that right. The asymptote, or where that limit is, that vertical asymptote, or where it goes undefined. So that'll shift it too. So this is what you're going to explore in your practice for today, is like what specifically these pieces do and how it affects the function and the graph itself. So that's pretty much it for us. We're just kind of talking about the basics. The big things to kind of pull away from this are kind of how we can manipulate it. It's a lot like the other functions we've dealt with, which for the most part everybody was very strong in. Also that this this reflection happens on that y equals x line. Okay, and just pay attention to also, I know I'm shifting around a lot, what happens with positives and negatives and where those are. Okay, that's going to tell us kind of where that reflection happens. Okay, that's it for now. Hopefully you enjoy the exploration, get some understanding on how you can manipulate those log functions. Otherwise, let us know if you have any questions. Have a good one.